So we're going to be looking at the quotient rule, and we are going to talk about how we can divide. Quotient means divide exponents with the same base. So in the warm-up, we looked at writing a general rule for this, and what we noticed is that every time if you take x to the fifth and you divide it by x to the third, if you expand these, this is x times x. And this is x times x times x. So once we expand these, we know that anything in the world, x divided by itself is just 1. So x divided by x is 1, x divided by x is 1, and x divided by x is 1. And I'm left with 2 x's in the numerator. So that would be x squared with 1 on the bottom, which we can just write as x squared. So what we noticed in the warm-up is we said, well, then look, if you take 5 and you subtract 3, you get 2. So our general rule in this case is going to be, if we have x to the power of a and and we divide it by x to the power of b, we will get the answer x to the power of a minus b. So let's look at a couple examples. We have to make sure they have the same base. So this is going to be x to the power, 7 to the power of 14 divided by 7 to the power of negative 2. So the base will stay the same. And then we have to take 14 minus a negative 2. So it becomes plus, so it will be 16, 7 to the power of 16. And again, 13 over 13, the base will stay the same. But the powers, so negative 5 minus a negative 6. So negative 5 plus 6, which will give us positive 1. All right, so let's look at if we actually have coefficients of our bases. So in this case, I have 24 divided by 6. Well, just like I did with multiplication, now I'm just going to simplify this fraction. And I know that 24/6 has a greatest common factor of 6/6. So I'm going to divide both by 6, and I'll get 4 over 1. Okay, so when I divide this, I'll have 4 over 1. And I have 5 g's as the numerator. And remember, it's the same thing as when we multiply. When we're dividing, anytime you have a variable by itself, or even a number by itself, it can always be raised to the power of 1. So this is g to the power of 5 minus g to the power of 1, which will give us g to the power of 4 as the numerator. Okay, and we can actually just write this answer as 4g to the power of 4. Okay, let's look at this example. Okay, oops, I don't know why that happened. Okay, so I'm just going to do one piece at a time. So let me look at the a's. When I'm dividing with the same base, I have a to the power of 3 divided by a to the power of 6. So that will leave me with a to the power of 3 minus a negative 6. And then I'm going to look at the b's. Remember, this is to the power of 1. So I have b to the power of 1 divided by b to the power of 4. So I'm going to do b to the power of 1 minus 4, which is negative 3. And again, we talked about how normally we wouldn't leave this negative here, but for now it's okay. We're going to talk about this next class. Okay, last one. Let's apply this new knowledge to scientific notation. So what we can do in this case is this very similar way of how we did this with multiplication. So I'm going to first look at these. I'm going to take 1.23 and divide it by 4.6. and that is 0.267. It's a little bit messy. 0.267. Okay, and then again, I'm going to look at these, and I'm going to say times 10 to the power of, and because I'm doing division, I'm going to subtract the powers. Okay, so 9 minus 4, which will give me 5. And then I ask myself, is this in perfect scientific notation? And the answer to this is no. So I actually need to move the decimal here, 2.67. And I made this larger. So to balance my equation out, I need to make this one smaller. And there you go. Take some really good notes in your small notebook, and good luck.